Good day, everyone. My name is Engineer Kene. I've come once again to teach you today, so relax and pay adequate attention. Today, we have come to discuss mathematics once again, and the topic that we are going to discuss today is cone. We want to discuss area of a cone and the volume of a cone, but we are going to start with the area of a cone. So follow me. Let's go. All right. We have cone. See, a cone looks like this. I believe many of us know what a cone is all about. See, a shape like this is what we refer to as what? A cone. A shape like this, we call it what? A cone. All right. This side, we denote it with L. We denote it with L. So this side, we denote it with D. That's diameter of the circular part. So here, this one we denote it with H. Why this one we denote it with R? All right, this is a cone. So L, which is this side, we call it a slant height. We call it a slant height. All right, H, which is this one, we call it a vertical height. Vertical height of a cone. R, we call it radius, base radius. We call it a base radius. Base radius. D, we call it base diameter. Base diameter. Can you see that? So that is it. When you have something like this and they ask you slant height, know that they are talking about this one. If they ask you vertical height, know that they are talking about this. If they ask you radius, most often they call it a base radius. We have this one. Base diameter, we have this one. From base radius, from base diameter, you can get base radius because base radius is equals to base diameter over 2, like this. All right. I want to explain something that is very important. You can use a sector of a circle to form this cone. For example, if I have something of this nature, this is a circle. All right, a sector may be something of this nature like this. If I remove this, this will become what? A sector of a circle. So this shape is what we call what? A sector of what? A circle. So remember, this is a certain angle. We don't know it because it's just a freehand sketch. So this is a sector of what? A circle. All right, you can use this to form a cone. How are you going to use this to form a cone? By bringing this and this together. When you bring this and this together, it's going to form this cone. When you just bring it like this together, it's going to curve and give you this shape we call what? Cone. All right, so here now, you notice that this is the radius of this circle. Can you see the radius of the circle? All right, so when you use a sector of a circle to form a cone, after forming the cone, you are going to have something of this nature. Something like this. That's what you are going to get. You notice that the radius of the sector of a circle this radius now, we now formed what? The slant height. The slant height of the cone. So when a cone is formed from a sector of a circle, the radius of that sector will form what? The slant height of the cone. It will form the slant height of the cone, not the radius of the cone. What it will form is what? The slant height of the cone. So anytime you are given a question that involves a sector of a circle being used to form a cone, just know that the radius of that sector of a circle will give you what? Will give you the slant height of that cone that is formed. All right. So let's talk about area of a cone. Area of a cone. When you look at this cone now, how many surfaces does a cone have? They may ask you this in examination, especially you people that are preparing for common entrance examination or even junior WAEC. They will ask you how many surfaces does a cone have. When you look at it, a cone has this one, which is number one, and it has what? Another one, which is this. So a cone has one circular surface and one curved surface. One circular, one circular, one circular, and then one curved. One curved surface. So we have surface here and the surface here. So two surfaces, one circular surface and the one curved surface. Can you see that? So a cone has what? Two surfaces. All right. Now, if you want to calculate area of a cone, depending on the area that you are talking about, you may be talking about surface area, that's the curved surface area, or you may be talking about circular surface what area. All right, let's start with circular surface. Circular surface of a cone. All right, if you want to calculate the area of circular surface of a cone, it's just area of a circle. We have the area to be equals to half pi r squared. That is the formula for finding the circular surface of what? Area of the circular surface of a cone. You have like this, where r is equals to what? You have it to be radius, and pi, you have it to be what? 22/7 like this. Can you see that? So this is the area of what? Circular surface of what? A cone. Then, if you want to find the curved surface, look at what we call the curved surface. This number 2. All right, we have curved surface. Curved surface. The area of the curved surface, we have it to be equals to, we have it to be pi RL. We have it to be what? Pi RL. All right, we have pi to be 22/7. We have r to be what? Radius. Can you see that? And we have L to be what? Slant height. Slant height of the cone. Can you see it? Slant height of the cone. All right, so that's it. We have curved surface area and the circular surface what? Area. All right, so sometimes they may ask you the total surface area. Total surface area. Total surface area means what? Combination of circular surface and what? Curved surface. All right, if you are asked to find the total surface area of a cone, what do you do? Total surface area of a cone, just curved surface area plus circular surface area. So we have total surface area of a cone to be equals to, of course, that of circular is this one, and that of curved surface is this. So when you add this thing together, it's going to give you the total surface area of what? A cone. All right, so let's move ahead and solve some examples that will enable you to understand it more.